This is 4.2, chapter 4.2 for Algebra 1, big ideas. As mentioned in 4.1, there were three different types of forms for linear equations. One form, the most common, is slope-intercept form. The second most common is standard form. And the third most common is point slope form. So in this section, 4.2, we're going to deal with point slope form. So as you can only assume, point slope form deals with a point and a slope. And as we see in exercise, the information provided, we have a point and we have the slope. So what does the general template look like? It looks like y minus y sub 1 equals m times the quantity x minus x sub 1. So we're going to fill in for the slope and we're going to fill in for the points. Notice these negatives are outside of that. So that negative is part of the template. We're just going to fill in the y1, so, and the x sub 1. So this is the x sub 1, and this is the y sub 1 values. So we're going to plug those in. So let's fill them in. Yes, it's that easy. Y minus whatever my y sub 1 value is, which is 5, equals m, which is my slope value, times the quantity x minus my x sub 1. And that negative for my x sub 1 is different from my template negative. Now we're going to simplify it. It's not very often that we keep a 1 value outside of a parentheses. Usually 1 goes understood. It is not written, but it's understood. But in this case, we will have a 1 to show. It's sort of a placeholder for the slope. You will see some that won't. You'll see some people write y minus 5 equals x plus 4. So 6 and 1/2 dozen the other. Me, I'm okay with you writing it. Here's our template. It's in our best interest to write the template so we can see the values. Y minus my y sub 1, which is 4, equals my slope, which is 1/3, times quantity x minus my x value. And that is in point slope form. Yeah, it is that easy. We like point slope. Let's write the template because it's always good practice and it helps us remember what the template is. Y minus my y sub 1, which is -6, equals -1/4 is my slope, times the quantity x minus my x sub 1 value. Now we can simplify this, and yes, we must simplify double signs. We will not be writing double signs in 8th grade because high school students, I know the answer key might say it in the book, but that is not good. You would want to simplify it. All right, write an equation in slope-intercept form of the line. Why are we doing slope-intercept? Why don't we do point slope form? Why did we come back to slope-intercept form? Well, I'm going to ask you to do both. I'm going to ask you to do slope-intercept form. We've already done this in 4.1. I think this might be a mistake. I think in 4.2 they meant to say point slope, but we'll do slope-intercept form. So we need the slope and the y-intercept. We see what the y-intercept is. It's where it crosses the y-axis. So the y-intercept is going to be -1, 2. And my slope is going to be up 1, 2, 3, left 1, 2, 3. So let's write that piece of information. Y-intercept is going to be -2. My slope is going to be up 3, left 3, which is +3 over -3, which gives me a slope of -1. So in slope-intercept form, we get y equals negative 1x minus 2. I would not write it in that fashion. I would expect, we just talked about when you need 1 in front and when you don't need 1 in front, that would need to be written as negative x. You would never write negative 1x. Now, I'm going to ask you to do a little extra. Well, I don't want to do crayon, and I just want to point out the slope. The slope is going to be, but I want you to write it in point slope form from this information. So the next part, the extra, would be write it in point slope form. And so point slope form is y minus y sub 1 equals m times quantity x minus x sub 1. So we know what the slope is. We know the slope is negative 1. The next question is, okay, what point are you going to plug in? Well, you can pick any point. I'm going to pick this point just for purposes, but we'll use negative 5, 3. Negative 5, 3 is going to be the point that we use using negative 5, 3. So minus my y value, which is 3, equals negative 1 times x minus negative 5, which is my x value. We're going to simplify it. We can write this. I would write it in this fashion. I would not write a 1. I would just write a negative sign out there, because that's how a high school teacher would expect you to write it. And this is one of an infinite number of equations you can write in point slope form. Why are there an infinite number of solutions in point slope form? Because how many answers, how many points consist of that line? There are an infinite number of points. So we can use any point to plug in for our y sub 1 and x sub 1. So there will be an infinite number of answers for point slope, and maybe that's why they chose to write it as slope-intercept form, which is, I don't know, you're sort of missing the point for 4.2. Write it in slope-intercept form. We will continue to do slope-intercept form, but we'll do the extra. So y-intercept, we can see what the y-intercept is. That is negative 4. How did I know it was negative 4 and not negative 3? Because take note of the increments. Each grid is 2 units. So I went down 2 units. That's negative 4. And then my slope is going to be, up 3, right 3. So another tricky. My y-intercept is going to equal negative 4. And my slope is going to be up 3, right 3, which is 3 over 3, which is 1. So my slope-intercept form is going to be y equals positive 1x minus 4, which gives me y equals x minus 4. We again would not write 1x. Now let's do it using point slope form. Point slope form, y minus y sub 1 equals m times quantity x minus x sub 1. Let's pick a point. Let's not pick the intercepts. We'll pick 6, 2. So using 6, 2. So my y value is minus 2. My slope is 1. X minus my x value. So you could leave it in this fashion. That would be okay. When we were using, if we were going to use, let's use the other point, 9, 5. Using 9, 5, that would look like y minus 5 equals 1 times the quantity x minus 9. And that also represents that equation. So there are an infinite number of equations you can write in point slope form for that line. There's only one slope intercept, but there are an infinite point slopes. Cool. This time they give us, so x sub 1, y sub 1. This is my x value in my second point. This is my y value in my second point. I'm going to do y sub 2 minus y sub 1 over x sub 2 minus x sub 1 to find the slope of the line. So the slope is going to be negative 6 minus 6 over negative 5 minus negative 3, which gives me negative 12 over negative 2, which gives me a slope of 6. Always reduce your fractions and slope-intercept form. So this, oh, I do like that. They didn't give me the freebie y-intercept. So I'm going to have to find the y-intercept using what point? Let's take negative 3, 6. Negative 3, 6. So we have the template y equals mx plus b. Let's fill in what we know. We know the slope and we know a point. So we know the slope, which is going to be m, and then we know a point, which is going to go in for x and y. So we'll substitute those values. My y value is 6, my slope is 6, times my x value, plus my b, which is what I'm looking for. So 6 equals negative 18 plus b, we're going to add 18, and we get 24 equals b. That's my y-intercept. So y equals 6x plus 24 would be in slope-intercept form. If we wanted it in point-slope form, I'm staying consistent, point-slope form, y minus y sub 1 equals m times the quantity x minus x sub 1. So y, what was my y value in that point I used? Using negative 3, 6. Using negative 3, 6. So minus 6 equals, my slope was 6, I think. Wasn't my slope 6? Yep. Times the quantity x minus negative 3. And we would simplify that. We would not leave it with double signs. So that would be one of an infinite number of solutions for point slope. X sub 1, y sub 1, x sub 2, y sub 2, negative 4 minus negative 4 over 5 minus 2, which is 0 over 3, which gives me a slope of 0. We can still do this. Y equals mx plus b. Let's pick a point. 2, negative 4. Using 2, negative 4. So negative 4 equals 0 times 2 plus b. Negative 4 equals 0 plus b. Negative 4 is my y-intercept. And my final answer is going to be y equals 0x minus 4, or y equals 0 minus 4, y equals negative 4. So that is the equation for the line containing those points. And that makes sense because it says y always equals negative 4. Does my y value always equal negative 4 no matter what I plug in for x? Yes, it does. Number 8, x sub 1, y sub 1, x sub 2, y sub 2. So 14 minus 18 over 7 minus negative 7, which is negative 4 over 14, which reduces to negative 2/7 is my slope. I want it in slope-intercept form. I'm going to use the point negative 7, 18. Using negative 7, 18, the template is y equals mx plus b. My y value is 18. My slope is negative 2/7. My x value is negative 7 plus b. Those are going to cancel. Denominator, numerator, negative and negative makes positive. So we have 18 equals 2 plus b minus 2 gives me 16 equals b. Let's put those two pieces of information together. Y equals, what was it? Negative 2/7 as my slope. X plus 16 as my y-intercept. That's a horrible 7. Cool. Good. Excellent. Here we go. Write a linear function, f with the given. Oh no. Well, yeah, I probably made a mistake on chapter 4.1. I didn't write f of x. Yeah. Go back to 4.1. Mr. Mack made a mistake. He forgot to write f of x as his final answer instead of y equals. He should have said f of x equals. But here are my 2 points. When you plug in -5, you get 2 as an output. When you plug in 7, you get -4 as an output. X sub 1, y sub 1, x sub 2, y sub 2, -4 minus 2 over 7 minus -5 gives us -6 over 12, which is -1/2 as a slope. Look how efficient and fast we are. Let's take a point. Which point? -5, 2. Using -5, 2. We have 2 equals -1/2 times my x value plus my b. Ooh, this is going to be interesting. 2 equals 5/2 plus b minus 5/2 minus 5/2. 2 as halves is equal to 4/2. So you're left with -1/2 equals my b. -1/2 equals my slope 2. So I'm not going to write y, I'm going to write f of x equals -1/2 x minus 1/2. That would be my equation. That was a fun one. I like that. And Mr. Mack did not make that mistake. F of x. Silly. Let's find the 2 points, -2, 1, and 12, 7. X sub 1, y sub 1, x sub 2, y sub 2. We have 7 minus 1 over 12 minus -2, which is 6 over 14, which equals 3/7 as my slope. Let's take the point -2, 1. Using -2, 1, you get 1 equals 3/7 times -2 plus b. I'm plugging in the y equals mx plus b, plugging in for m and the x and y, and I get 1 equals -6/7 plus b, add 6/7, add 6/7. 1 is equal to 7/7, so we get 13/7 equals b, and my slope is, what's my slope? 3/7. So y equals 3/7 x plus 13/7. I would not give that as a mixed number. I would give it as an improper fraction. Oh, and it's not y, it's f of x, Mr. Mack. Silly. Still making that mistake. The first point is -8, 12. Second point is -3, -3. X sub 1, y sub 1. X sub 2, y sub 2. -3 minus 12 over -3 minus -8. -15 over 5, which gives us -3 as the slope. Let's take the point -8, 12. -8, 12, so we get 12 equals -3 times -8 plus b. 12 equals 24 plus b, minus 24 minus 24. -12 equals b. That's my y-intercept. And my slope was -3. Oh, I almost did it again. F of x equals -3x minus 12 would be my formula. Tell whether the data in the table can be modeled by a linear equation. Explain, if possible, write a linear equation. So the first thing we have to do is make sure the slope is continuous across all the points, that it has a continuous slope. So we look at that, that's +1, that's +1, that's +1, that's +1, that is -0.5, that's -0.5, that's -0.5, that's -0.5. So those increments are consistent because the slope is going to be the y's over the x's, the difference in y's over the difference of x's. So we would get negative 0.5 over 1, which equals negative 0.5. And that is the same relationship for each of them. It's the y over the x. It's the y over the x. The y over the x. The y over the x. So each of those simplifies to negative 0.5. So we have our slope, and we know if we want to write it in slope-intercept form, the function y of, so if we're going to write it, we're going to put it in slope-intercept form, and we're going to pick a point or a solution. Let's pick 1, 3 using 1, 3, so we get 3 equals negative 0.5, which is my slope, times my x value. And we get 3 equals negative 0.5 plus b. Let's add 0.5, add 0.5. We get 3.5 equals b. So my equation for that line would be y equals negative 0.5x plus 3.5 represents the data in that, oh yeah, 12. Good. Okay, cool. That's good. Yeah, that's the formula. We like that. Let's look at this one. So that is plus 2, plus 2, plus 2, plus 2. Okay, that is plus 1. That's plus 2, that's plus 4, and that is plus 8. So if we're going to put the y's over the x's, my first slope is going to be 1/2. My next slope is going to be 2 over 2, which equals 1. And then my next slope is going to be 4 over 2, which equals 2. And then my last slope is going to be 8 over 2, which equals 4. So each of my slopes are different. So that means it's not constant. A linear line has a constant slope. So this is not a linear equation. It is nonlinear. And, well, we can write an equation, but you haven't learned that yet. So not a constant slope. In Algebra 2, you will learn how to write an equation for a nonlinear line. Not today. Not today, boys. What movie? Famous hockey coach. Very famous. The hockey coach name? Herb Brooks. We were going to name our child, one of our children, Brooks, for that very reason. Herb Brooks, coach of the 1980s Winter Olympic Team USA in Lake Placid, New York. Number 14, to make your own juice, there is a base cost for materials and a cost per fluid ounce of juice. The table shows the total cost of making different amounts of your own juice. Can the situation, be modeled by a linear equation? So let's check and see if those are constant slopes. Plus 4, that is plus 5, that's plus 5, and that's plus 5. So our slope, yes, our slope is going to equal 5/4. Now, how do we find the y-intercept? Well, we do the same thing. Y equals mx plus b, plugging in for m and plugging in for a point. We have a point. In fact, we have 4 points. One of those points using, let's use one of those data points, 417. 417, so 17 equals, my slope is 5/4. That's my m. My x value is 4, and we can find my y-intercept. So 17 equals 5, because numerator cancels with denominator, plus b minus 5 minus 5. 12 equals b. So my equation is going to be y equals 5/4 x plus 12. Do you know what 12 represents? That is my starting fee, my initiation. We've talked about this. It's my initiation fee, or my starting fee, or my initial costs, costs for materials, and then the cost per fluid ounce of juice. So it's going to cost, this is materials, initial materials, and this is going to be the cost per ounce. Cost per ounce. And that is going to be, what's that, $1.25. So you could write y equals 125, or let's do C equals 125 O for ounces plus $12. So that's what my formula is going to include. So what is the base cost for materials? $12. What is the cost per fluid ounce? The cost per fluid ounce is $1.25. Yeah, let's go. And part C, you have $100 to spend on making your own juice. What is the maximum number of fluid ounces of juice you can make? Well, okay, there's a couple ways we can do that. We can set that equation equal to cost equals 5/4 x plus 12 and subtract 12. And now we can get, what's that, 88 equals 5/4 x. Let's multiply by the reciprocal, which is 4/5. 4/5. That's ugly. Why is it ugly? Because they're not going to be able to cross cancel. We like cross canceling. What's that's 32, so 352 over 5 equals x. Well, let's do 352 divided by 5 gives me 70.4, and this is the number of ounces. So we could only do 70 ounces. All right, 70.4 fluid ounces. Apparently, we can have partial ounces. So if I have $100, I get to spend 12 of that on my materials. And then I can be left with, then I have enough money. I have $88 that can go towards the juice. The juice. Oh yes. A lot of work there. I would probably watch this video a couple times to make sure I comprehend all of that.